Hello students, so continuing our lectures on bioceramics, we will first start with the nanoparticle and bio interactions. Now, by bio interactions, what we mean is when we are creating a bioceramic and we are allowing it to be implanted in a body, so the nanoparticles, say the bioceramics is in the nanoparticle form, so it will interact with the cells of the body, and this is actually the foundation of uh, biocompatibility of the bioceramic. A lot of simulations have been done using molecular dynamics, molecular dynamics, and there is a dynamics called coarse grain molecular dynamics. This academic molecular dynamics is AMD, then coarse grain molecular dynamics, and dissipative particle dynamics. Short DPT. Now, what is important is that one modeling tool may not be is specific to a particular use, and to have a diverse or a comprehensive modeling technique, we need to have something called a multi-scale simulation methods. By multi-scale simulation methods, we mean if there are two programs running, so output of one is becomes the input of the other program. So that means the programs are linked. This is what is called as multi-scale programming. However, in multi-scale or in applying different multi-scale programming, we need to take care of two things. First of all, we need to take care of the time and to take care of the space. That means it's space and time are two important things. So that means in total or as a whole, we can call it as spatio temporal coherence. Like for example, if we in this case, if we are using these three models AMD, CG, CGMD, and DPD, then it has been observed that in terms of accuracy, this is the highest. Now, AMD is highest in accuracy, whereas DPD is highest in spatial temporal coherence. So if we plot AMD versus with all the techniques versus the temporal and spatial coherence, like we plot AMD here, then CGMD, then DPD, then the accuracy will be maximum here, and it will go down, whereas in the case of spatial temporal coherence, it will be maximum here and it will go down here. So if you look into the matter, this is where the balance is has to be maintained. Actually, it also depends upon what is the system. That means if we have a system where we want higher accuracy, that means, and this is spatial temporal coherence. So we need a system. When we require higher accuracy, we'll go for AMD, and if we require a system where we require higher spatial temporal coherence, then we will go for DPD, and if we require a balance, then we will use the CGMD. And this is done for the case of POBC liquid molecule. Liquid molecule. Bioceramics are also used in dental applications. For a tooth structure, if you look closely, a tooth structure, it consists of, so if this is the tooth structure, it consists of the dentine, then pulp, and lastly you have the bone here. This is the bone, and this is the pulp here, this is the pulp, this is the dentine, and this is the bone, and it is arranged to the other by a bridge. This is the bridge. Now at the ceramic point ticks indicated here, this is the place where the crack growth takes place. This is where the cracking can take place and can propagate. These are called the dental point ticks. Dental point ticks. And so the crack initiation and propagation were studied for analyzing the fracture strength of these. Now these materials are also bioceramic materials. This bridge is made of a bioceramic material, and so a fracture strength is created. and FEM simulation have been done. Now, finite element modeling is done to analyze the stress, and it also the optimization and is dependent on the principal stress and strain energy density. Now, in dentistry, we often do something called root canaling. Okay, so what is done in root canaling is, this is the teeth, and this is the pulp. So we remove the pulp here. So the pulps are removed, replaced by rods or canals. These are the root canals. And then we cover it with a cap. This is the typical RCT test. Now, in this root canaling test, if there is an increased use of calcium hydroxide, some use of calcium hydroxide, it may cause an increased chances of root fracture. Root fracture. So it cause the root fracture chances may increase. So what we do something called an apexification. Use an apexification, and what a calcined barrier is created, and calcified barrier is created without using any apparent pathosis to induce root and closure. So what we do is a simulated open apex was created. Simulated open apex is created using polyvinyl tubes. And then they are used in either two ways. Either they are used through amalgam, then gutta-percha, and MTA Angelus, or new MTA plus. These are bioceramics. These are the bioceramics. So we have different areas. This is the amalgam. Then say this is the gutta percha, and say this is the NTA or Neometal Plus. So it can follow this track, or it can follow a different track where you have glass ionomer cement. Then we can have a damp cotton. Lastly, the same thing is here. So this is the glass ionomer cement. This is the damped cotton, and this is the new Angel Plus or new MTA Plus. So a simulation of these can be done of an open apex is done. Now the sealing ability of the root canals using gutta percha ceramic while evaluated to sealing ability of root canals by gutta percha bioceramic was evaluated based on the bacterial leakage. Based on bacterial leakage, and it was found that this combination of GP epoxy resin showed good performance in terms of resistance to leakage, resistance to bacterial leakage, and 3D compaction. So this is the one shown by this epoxy. Now, microcomputed tomography images of these roots were taken. So, if these are the roots, it underwent microchromatography, and this is a blue color region was obtained. So this is the region which indicates gaps or voids.